lab tray.
Yeah.
I was thinking FRO and forensics. Take only two.
Total classes?
First off, I want to make sure this is not
Because
due
they're
until
only
the end
senior
of.
projects.
Taking
Yeah, that's
Spanish.
not right.
Hmm?
Taking Spanish.
You right?
Yeah, it's not right.
Why?
Push it at the end. I haven't covered it yet.
Because I don't, because I
I
can.
gotta make sure. Make sure I don't screw you guys over. Alright. So lab 3 is a little bit harder. Lab 4 is easier, especially once you've done lab 3. You can do lab 3 in GNS3. You can do it in Packet Tracer, to be honest with you. It's not terribly easy, but a lot of the stuff we've covered. The stuff that we haven't covered, I'm going to kind of spoon feed you. It's a review of 347, 307. Hopefully it's a review of 347. Well, that's what I'm going to spoon feed you. Okay, so you go into.
Remember you said you wanted to do packaging.
Yeah, it's okay. We'll do a packet tracer. It can be done. It can be done. So 3 routers, 3 switches. Actually, 4 routers, 3 switches. So I'm going to use 2911. And for my switches, I'm just going to use a generic 2960. So connecting everything up, I'm going to use everything with a straight through cable. And on the lab, this doesn't matter because it's fast Ethernet. I'll know it looks like a lightning bolt, like a zero connection. It doesn't matter. I'm putting a switch in here. I'm adding a switch in here. This is switch 0. So fast Ethernet 01 goes to fast Ethernet 00. Alright, in this case, gig 01. Doesn't matter what you hook it up to. The 00. And then 01. Zeros. It's hard to read. I'm just doing the basic connectivity. Okay. Just look something similar, kind of sort of like that. Alright? Now, I always suggest that you read through the entire lab before you start. Okay? A lot of students will start, okay, what do I do on number 1? And we'll go to number 2. What do I do on number 2? Well, what happens if I ask you something along, number 4, number 5 that changes something you did on number 1 and number 2? Well, you can catch it, I'm sure. It's fine. But if you read through the entire lab, you're like, I cut to the chase. And skip a step, which is not bad. Right? So we read through the lab, configure all routers and switches with the host names depicted in the diagram. All right. Configure all routers and switches with the IP addresses depicted in the diagram. So we're going to do IP add on the interfaces, add all that. Okay, that's pretty easy. configure the routing protocol domains according to the diagram. Ensure 100% connectivity between all routed networks. Note that route redistribution will be required. Okay, full lock connectivity can be tested by doing this. Okay, so we'll get to that. So I gotta put in OSPF on the routers. I gotta put in OSPF in a different area down here. EIGRP down here. This is where I'll have to do redistribution. And it looks like this. I might have to add a static route up here. Okay. On R1, configure and apply an access control list to prevent RFC 1918. You've done that already. On R1, I skipped number 4. Configure a default static route to the ISP router. You've done that already. Re-IP what? Re-IP the core transport network from 201.68.109.128/25 to 201.68.109.128/29. Wow. So I make you go through and IP everything, and then I make you go and change it. Well, since I was smart and I read through the lab, why do I need to do that? I'll just go with it from the word go, right? Makes sense? Okay. This is a common trick on certification exams. And that's why I have it in here. If you ever go and you do a certification exam for Juniper or for Cisco and it's a hands-on lab, look for stuff like that. That is something that if you go and you take 5 minutes to read through the entire lab, you'll catch it and you may save 20 minutes later. Everybody understand that? Test taking tip. All right, set up PAT, set up NAT, set up a DHCP server, set up AAA on the routers to point to a radius server, create an ACL on R1, create an ACL on R3, configure area authentication. Okay. Some of this is you've seen before, some of it you haven't. I get that. So now that I know that, oh, I caught this number 6 to IP everything from a /25 to a /29, what's the difference there? Anybody know? Your IP is not going to change. What's going to change? The subnet mask is going to change. That's it. Okay? And not only will the subnet mask change, but if you had already configured your routing protocol, your OSPF, your wildcard mask would have had to have changed as well. That's where the time saver comes in. Okay? So remember that /20, ignore that /25, it's a /29. So with that, let's do this. I'm going to work from top to bottom. So I'm going to work on the ISP first. Or not. So its host name needs to be ISP, and it has to have an IP address of 201.68.109.97/30. That I will bring up R1. Helpful tip so you don't get that can't translate error. No IP domain dash lookup. It's not required, I won't grade it. It's a time saver. Alright? Let's see, what else? Okay, so I'm on R1, and here in Packet Tracer, I can't do that in Packet Tracer. Whoops. So I have fast Ethernet 0, 0 on the the outside, 0.1 on the inside. Actually, gigabit Ethernet. Int G00 is on the outside. Add 201.68.109.98. This is where I'm getting it from right here. And remember, 29-bit subnet mask. That's .248. I have to turn the interface on. There you go. Go to your next interface, gig 01, which is on the inside towards OSPF. IP add 201.68.109.129. Here's the network. There's the actual IP. Again, a 29-bit subnet mask. It's .248. And turn it on with no shut. So R1's done. We go back to the ISP. Host name ISP. And interface gig 00, which faces me. IP add 201.68.109.98. Excuse me, 97. .30-bit subnet mask. A 30-bit subnet mask. Ooh, did I do that wrong on the R1 router? I may have. I'll go back and look. No shut. Okay. That's all you really have to do on the ISP router. That's all I'm really going to grade on the ISP router. So we're going to shut the ISP router down for now. The ISP router is what I use for grading. So I'll go into your ISP router, I'll set up routes on it, and then I'll check. I'll do gets and everything to find IPs, or I'll do ping traces, things of that nature. Alright, so on R1, let's just do a show run. I may have goofed up the subnet mask. I did. So 98 is not supposed to be 248, it's supposed to be 30-bit, which is 252. That's okay. This happens to students all the time. Go back into the interface, G0/0. You can delete it if you want to with the no command, or if you just put in the IP address again with the correct subnet mask, it overwrites it. There you go. Easy. Excuse me a second. Sorry. All right, so from there, on router 1, home on R1. Change that. There we go. I need to create a, I know in reading, I got to create a default route, and I've got to add this into OSPF. So I've got to make a default route to .97. IP route, it's all zeros. And then my next hop, 201.68.109.98. 128.109.97. I've got to set up OSPF on R1. Right? To set up a routing protocol, you use the router command, and then whatever the protocol is. And then any parameters that you have for that routing protocol. So, when I set up OSPF, what do I have to tell it? What process ID it's going to participate in. That's what that 100 is here. That's the process ID for OSPF. So, router, OSPF, 100. Enter. Alright? Then, under a routing protocol, in order for it to engage in participation, I've got to tell it what networks it's going to participate in. So here it's going to participate from R1's perspective. From R1's perspective, it's going to participate in the 201.68.109.128 slash what? Who's paying attention? 29. Thank you, Melissa. Good job. So net 201.68.109.128. It's the network. It's not this number. That's on the interface. It's the network number. And then it's a wildcard mask, just like an ACL. All right? A numbered ACL. So it'll be inverted. 0.0.0. What's the inverse for /29? 256 minus 248. Actually, 255 minus 248 is 7. I believe that's right. And finally, what area it's participating in. I tell you right there, area 0. All right. Let's go over here to R2. I know I have to give it a host name. All right. I know that the gigabit 00 faces OSPF. Okay.
So you wouldn't do the no domain lookup on our.
You can do that anywhere. That's optional.
Oh.
That's not going to be great. But if I get out of the interface, no IP, domain dash look. Okay, so that's if you mistype a command, it will automatically go and try to translate it to a DNS address. This stops that from happening.
Okay.
And it's a time saver. Especially if you got like fat fingers like me and you mistype everything, every other command. Alright, so back into my interface, gig 00. IP add 201.68.109.130 255.255.255.248 no shut. Okay, and its internal one is int g0/1 IP add.
You spelled it wrong.
Thank you. IP add 192.168.50.1. Where did I get that from? Right here. 24-bit subnet mask. It's easy. All 255s with 0. No shut that interface. Go back to global configuration mode. Now we've got to not only put this in OSPF, but we've also got to put it in EIGRP. So we're not going to set up one routing protocol in R2. We're going to set up 2. So let's do OSPF first. Router, OSPF 100, net 201.68.109.128 0.0.0.7 area 0. Watch what happens. I'm going to pull R1 back over here. I've already done this in R1. You're going to see it in R2 as well. As soon as I hit enter, that's going to kick off the OSPF negotiation and election process. Give it a second, wait for it. Bingo. What they've done here is they've negotiated with one another that they're going to be neighbors in the OSPF routing process. Okay? And what they've done is they've gone through an election process to decide who is going to be the controller of the OSPF domain at this point in time. Okay? And there's a whole set of criteria that it goes through. Now you can manually tell the process on either router which one to elect. If you don't, it goes through, different processes, right? Who has the most bandwidth, if that's equal, who has the most who has the least loading time, things of that nature. In an initial setup like this, what it's going to come down to is who has the lowest IP address. So, if memory serves me correctly, R1 should be the DR, the designated router holding the database, the master database. Okay? So if I leave the router 2 and I do a show IP OSPF neighbor, I can see that .129 is my neighbor and it is my designated router. Why? Because it has a lower IP address than. Okay? If I come over here to R1, I do the same command, show IP OSPF neighbor. Oops, if I can spell it right. Show IP OSPF neighbor. Okay? I can see that router 2, I'm sorry, is my backup designated router. So if I fail, he'll take over. Last but not least, let's back on R2, let's add in EIGRP. Back in global configuration mode, and this time router, EIGRP, and then the autonomous system number, which in this case, it's hard to see down here, it's 25. You add the network in, very similar as you did in OSPF, except you don't have to give it an area number. So network 192.168.50.0 and 24-bit wildcard mask. Now, one other thing I want you to do, you can do it, it's optional. You won't get marked off, but it's just a good practice to get into when you're setting up EIGRP as a routing protocol, and that is to put in no auto summary. Okay? Anybody know what auto summarization is? I know you had this if you had Dr. Pike. I know he went over supernetting. It supernets for you automatically. Okay? Now in EIGRP, that can be a hassle if you don't have it manually set up correctly. In this case, we're only dealing with one network. It doesn't matter if it goes in or not. It's just a best practice to always put in no auto summary. All right? And last but not least, we need to, actually I'll come back to that. I'm going to do R3 real quick and I'm going to come back to the full connectivity piece. There's two things that you also have to kind of keep in mind. So let's go back to, let's go into R3 now. Give it its host name. Do a no IP lookup. And let's get its IPs in there. So its gig 00 faces the OSPF network, which is IP add 201.68.109.131. shut. And then int gig 0/1 IP add 172.21.0.1 24-bit. Shut. And now I'm going to add in these networks into OSPF. I'm going to add in area 1 first, and then area 0, because I want you to see the loading again. All right. Router OSPF 100, network 172.21.0.0, area 1, and then network 201.68.109. Okay, area 0. So when I do that, if I watch, say, R1 again, sure. Net 201.68.109.8. Come on. There it goes. So it paired with both routers. Right? Now if I look at R1 and I look at my routing table with the show IP route command, I see an inner area route. I see the 172.21 network via R3. I see my static route. What am I missing? What am I missing? Well, we're not done yet. I said I was going to come back to. Do the redistribution for EIGRP. What network is in EIGRP? At 192.168 network down here, right? Okay. If I go to R3 and I do a show IP route, I should not see that either, right? And I don't. Oh, wait a second. I'm missing something else here in R3. I don't see this static route. I don't see a way to get to the internet. Well, that's not good. I could throw a static route there, but I said in the rules that are in the instructions, you only have one static route on R1. So there's an additional step I got to do on R1 in OSPF, and there's an additional step I've got to do on R2 in OSPF to make this a fully converged network. I've got to, on R2, tell OSPF about EIGRP. In OSPF, router, OSPF 100. Redistribute EIGRP, the autonomous system number, which was 25, and I want to include subnet mask information. So the full command, redistribute EIGRP 25 subnets on R2 inside OSPF. You do not have to do anything else in EIGRP. A lot of students go in there and they do the same thing in EIGRP because they think that, oh, it doesn't have to be. Only in OSPF. There you go. That'll take a second to reconverge. I go and do show IP route again in R1. And now I have an additional route. I have an E2. Now I see the 192.168 route. But even on R2, right, I see my inner area route. I still don't see that static route. Back on R1, I've got to go into OSPF And you would think, oh, well, that was a static route. I've got to redistribute static, right? No, it won't work. If you had other static routes, that was not an all zeros route, that would be correct. Because it is a default route, you have to do a special command called default space information dash originate. That's a higher level command at the CCNP, CCIE level, right? That throws a lot of junior network engineers off, especially if you're dealing with routing issues. So the command is IP, default dash information space originate. That's the command. Take a picture of it, snapshot it. Once you do that, keep that up there. If I go back to either R2 or R3, I do show IP route. Now I see that default route pop up. So once you see that default route on R2 and R3, once you see the EIGRP network from R1 and R2, okay, you have full connectivity. A lot of work just to get 10 points, I know. Trust me, I know. But that you need that 10 points to get any other points on the lab. Okay? That's why I let people record this class. It's a lot of steps, a lot of instruction. All right. Jumping back in here. So we've done number 1, we've done number 2, we've done number 3, we've done number 4, that was that default route. Number 5 I'm going to leave to you. This is a ACL that will prevent RFC 1918 networks from being sent out to the internet on R1. So there's a couple different ways you can do this. You can do a standard ACL. You can do an extended ACL, I didn't specify. But source IP, we don't want them going out. Whatever interface you put that on, I'm just going to look at is it coming inbound, is it going outbound? Does that make sense? You'll be fine. All right? So I'm going to leave number 5 writing that ACL to you. Number 6, re-IP, oh, we did that. Number 7, we're going to set up NAT. All right? Number 8, we're going to set up PAT. Number 9, we're going to do a DHCP scope. All right? AAA. And then more ACL work. I want to kind of leave it off here for now because that's a lot to ingest. On Tuesday, I'm going to finish this up in week 8. On Thursday next week, I'm going to go into the final lab. Now, the final lab is a lot easier than this lab. Okay? Believe it or not, it's a lot easier. We'll do it in Packet Tracer as well. Once you get through this lab, right, lab 4 is really easy. Really easy. You guys have any questions on this? Do you want me to repeat anything? I'm not going to repeat the whole thing. But if there's some, how did you do the redistribution? How did you do the deep? I'll go over that again. I'll show you in the config. Okay then, I will wish you a very good, happy weekend. Happy Mother's Day.
Meine Mutter ist a Liebe, a herzensgute Frau. Ich möcht sie nicht missen, auf sie da kann ich bauen. Ob ich einmal ankomme, zu ihr da kann ich gehen. Sie sagt, es wird schon werden, mein Bruder wird schon sehen.
We're going to address translation is basically going to allow us to have a device, in this case a server, right, that's sitting on this network over here off of router 2, switch 2, to the internet. And this handy dandy little table here, see, gives you the translation, what the local IP is, that's corresponding to the 192.168.68.50, and the NAT IP. Now, you can, if you so want to, add an in device here and give it an IP and all that good noise if you want to. If that makes it easier for you, that's fine. All I'm really going to look at though is where you're going to put NAT. So I'm going to put NAT on R1. Excuse me. Okay, I'm going to put it on R1. I think I actually tell you in the instructions to put it on R1. Yeah, so they want you to put it on R1. Okay, so the configuration for that is to use the IP NAT command in global configuration. So conf T and IP NAT source static. So we have to define whether it's an inside address or an outside address. All right, an outside address outside or inside. So primarily, if your devices are going to be communicating outbound, it would be an inside. If they're going to be communicated to from outbound, it would be outside. In either case, it really doesn't matter. All right, just as long as the translation happens. So I always tell students to do the translation on the inside. All right. So inside source, static address, and then whatever the inside IP is, your local IP. So reference back to that table, you have to set all these up. So I'm going to do the ADACS server, which is 192.168.50.4. Okay, and then your translated address, 201.68.109.137. Okay, and that's pretty much it. Oops. Okay. So if I show run, you will see that is it right there. There's one additional step. You need to go through and do all those individual additional translations. So you're going to need one for the file server, one for the SMTP server, one for the web server, one for the BlackBerry server. Okay? 1 to 1 to 1. All right? When you do that, you have to do one additional step on the interfaces. Right? So you need to understand which interface is your inside interface, which interface is your outside interface. Really easy. Your outside interface is closest to the internet. Okay? Kind of self-explanatory. So my inside interface on R1 is FA01. Or in this case, gig01. And I have to give it the command IPNAT inside. Right? And gig00, which is on the outside, I give it IPNAT outside. So when we do a check here, see that we have IPNAT outside on the outside interface, IPNAT inside on the inside interface. We have one of our static NAT statements there. You need to do the additional 4. Questions on number 7? All right, moving on to break. Set up PAT for R1. Create PAT entry so the workstation subnet 172.21.00/24 is translated out R1's external interface. This is done very similar to those static statements with a slight modification. Okay. Again, go back into global configuration mode. IP NAT. Oh wait, we have to define the traffic. We've got to be able to tell the PAT statement, if you see traffic coming from this source, right, do this. It's kind of like an if-then statement. So we've got to set the interesting traffic. We know the interesting traffic is going to be traffic coming from 172.21.00/24. So what type of an access list should I write if I only need to define source IP?
Standard.
Correct. I can make it just a simple numbered ACL. IP access dash list 10 standard 10. Okay, and then permit 172.21.0.0 wildcard mask. That's it. I don't need to have a deny, do I? Because I already have one there. I don't need to permit anything else. I don't need to do a permit any because I only want to permit that subnet. All right? So then when I make my NAT statement, IP NAT, again, inside, because I'm looking for traffic coming from the inside. Source, instead of static, I want to reference an access list. So I'm going to type in list. And then the number, I gave it number 10. That matches up with the ACL I just wrote up here. Okay? Next, I got to tell it, well, what do I want to translate? Do I want to translate to another pool, like a pool of public IPs I might have? Or, in this case, what I'm asking for is for you to translate it to the IP address of the outside interface. So it's going to be interface. And then that interface is G00. And last but not least, I want to use the overload command so it creates a PAT, port address translation, so that I can have multiple inside addresses use that one single interface address. Okay? So, please note, in order for PAT to work, you also have to have IPNAT outside and IPNAT inside. That's already been done. So you killed 2 birds with one stone. That's why if you forget this command, you'll still get 4 points because you did those 2 commands in the previous step. If you don't do those 2 commands for the interfaces, you won't lose 4 points for number 8. You'll lose 4 points for number 8 and 2 points for number 7. So it's a free 4 points to do the commands. Questions on number 8? Okey-dokey. Number 9. Configure R3 as a DHCP server. You guys have configured a DHCP server previously, yes? Alright, didn't I make you do that? Okay, so I'm going to skip that one. That's on you. Set up AAA on R1, R2, and R3 so that users are authenticated by the Active Directory server. Use Cisco 123 as your radius key. You've done that before. That's a review. Homework week 3, if I'm not mistaken. Week 2, yeah, week 3. Week 2 or week 3. Please reference back. I'm doing that. Need help? Ask. 10. So now that we have got most of this set up, now we get into the high-end security piece of this. So there are several sets of access lists that you have to write on R1 and R3. You don't have to write any access lists on R2. R1 is a general access list to permit traffic from the outside world into those networks. Okay, so remember, you used NAT previously. Okay, so I don't know if I covered this. I will now. In a router, as packets are coming in an interface, all right, they hit the ACL first. If there's an ACL tied to that interface. So destination addresses in the IP packet will be pre-NAT. So destination packets will be pointed towards the public IP. If the packet passes the ACL, then it gets translated, then it gets routed in a router. In a firewall, it's all kinds of backwards. Okay? It gets NATed first. If there is no NAT, packet gets dropped. Right? If there's a NAT statement, it gets translated. It then goes to the ACL. If it passes the ACL, then it goes to the route table. And this is just in Cisco. Palo Alto does it a little bit differently. Checkpoint sends it to the routing engine first before it goes to the ACL. It does like the ACL filtering last. I don't know why, they just do it that way. Alright? So things are kind of convoluted. But the hardest part is just understanding where NAT happens in a system. So with that, bring back R1. Alright, so we need to create an access list and apply it to the outside interface of R1. This is, this is going to be an extended ACL because we're dealing with source and destination as well as protocol, destination protocol. So I'm going to make a named access list. IP, access list, extended. I always like to name the access list personally for the direction the packet is coming from and going to. Alright? If you name it something else, that's fine, I'll figure it out. But it's just a good practice to do from and to. So this is coming from the outside and going to the inside. So I'm going to call it out-in. I'm going to hit enter. Now I'm going to go into access list configuration mode. My first one here for number 11, allow SMTP from the internet to 192.168.50.25. Okay, so permit. SMTP uses what protocol? Oh, you gotta think in this stuff? Yeah, we do. SMTP is, I'll give you a hint, is it UDP or is it TCP? It's TCP. Alright, now from the internet, where do you think my source is? From anywhere, right? I won't be able to accept anywhere. Any? Where's my destination? To a specific server, right? So I have to use that keyword host. And then the IP address. Now, I can't put it in 192.168.50.25 because that would be post-NAT, so I need to go back and reference my table. Our number 7. So there's the IP address. .168.109.139. And what port do I want to send that to? What port is SMTP? TCP, but what port does it communicate on?
25.
25. That's that. Allow BlackBerry services from 201.60.108.75 to 192.168.50.125. I'm gonna leave letter B and letter C to you guys. C is really easy. That's gonna be port 80 and port 443, obviously. All right. BlackBerry services, do a little bit of reading on it. What does BlackBerry use to communicate? Yes, Blackberries are still used from time to time. They used to have specific port numbers, but now they use general port numbers. Okay, general port numbers. So B and C is on you, but that is the basic concept. Now, once we write the ACL, what do we have to do? We got to apply it to an interface, right? What interface are we going to apply it to? The outside interface. So, int G0/0, which is the outside interface, IP access group out-in, and is it going to be traffic coming into the interface or leaving the interface? Is traffic coming in that I'm filtering, or is traffic going out that I'm filtering? Out? No, in. This is traffic coming inbound. Out to in, so it's coming inbound to the interface. Don't forget that. Number 12. Create and apply access control lists on R3 using the information below. So here, we're going to allow hosts on Workstation Network to access Active Directory services on 192.168.50.4. So on R3, our Workstation Network 172.21.0.0 has to communicate to our domain controller, which is 192.168.50.4. There's no NAT here, so we're not worried about NATing. We're just dealing with the normal IP address. Okay. Block workstation host from accessing 192.168.50.43 by SSH. Block all workstation hosts from being accessed by the telnet. Ensure all other services are allowed into the workstation network. So this is tricky. So allow hosts on the workstation to network to get to the AD server. Okay, that's one ACL. Block them from accessing ACS services on the same server. That's still in the same ACL. So we're talking about two different entries. Block workstation hosts from accessing 192.168.50.43. That's still via SSH. That's still going to the same network, so that can fit onto that ACL as well. So A and B are going to be entries on one ACL. Block all workstation hosts from being accessed via telnet. Ensure all other services are allowed into the workstation network. So we need to have not one, but two ACLs for 12. Not one, but two ACLs for 12. One inbound, one outbound. You can put them on the same interface. I would suggest you put them on the FA01, the fast Ethernet interface. Okay? You can put one on this interface and one on this interface. There's several ways to do this. Guess what? They're all right. Well, most of them are all right. Primary thing is I'm looking for two ACLs. Okay? So, number one is tricky because I'm looking for all 80 services. At least I'm looking for about 4 or 5 ACL entries for different ports. Ports that use Active Directory. Some of them are really common. Some of them not so, well, one of them not so common, but that's okay. All right, if you miss one entry, you lose a point. Don't forget to apply the ACL. ACLs. I've already given you enough hints that you have to have 2 ACLs for 12. All right, number 13. Number 13 is a little tricky, okay, if you haven't worked with it before. We're going to configure area-wide authentication for all of OSPF Area 0 using the MD5 key of Cisco. So this is simply done in the router protocol, routing protocol. So, but in order to do it, you've got to break everything. So I'm going to start on router 3. All right. Router OSPF 100. So area 0, authentication, message digest. All right. And then we have to go onto the interface. In this case, it's G00. And we have to set up IP OSPF, message digest key, the key ID, which is 1. Oh, there it goes. Take that back. Let's do this first. I think we only have to do this with, oh, we do have to do the, interface component, my bad. So int G0/0, IP OSPF, message digest key, the key ID, which I'm just going to make key ID 1, MD5, and then the password, which is Cisco, what I make it, Cisco 123, something like that. Key is Cisco. All right. Now we go into R1. You have to do the same thing. So in this case, it's router OSPF 100, area 0, authentication, message digest, then interface G0/1, IP OSPF, message digest key, E1, MD5, Cisco lowercase. Bam. You see as I do that, it comes right up. So what this does is prevents rogue routers in your routing domain. Okay? So I just can't attach a router, kind of guess what, or do a little bit of sniffing, find out you're running OSPF. Oh, hey, they're running OSPF. Oh, hey, they're running process ID 100. Oh, hey, let me attach in there and just take over as your designated router. All right, let me grab all your routing tables and help me to, recon your network. Or worse, let me break everything in OSPF so I can take down your network. This helps to prevent that. Okay, so one more time on R2, we'll call it a night. Or, well, I'll ask if anybody has any questions on anything, I should say. Router OSPF 100. Area 0. Authentication. Message digest. Int G0/0. IP OSPF. All process ID 100. Authentication, message digest, and 1. All right, why are you goofing up here? Message digest key 1, MD5. Cisco. So silly. We should see it come up in a second. There it goes. So, 2 commands, one in the routing protocol, one on the interface. Kosher? Kosher. Questions? Short night tonight. Next week we're going to cover Lab 4. It's going to take about as long. Yes, sir?
Is there any like, what do you think would be the best way to test to make sure that everything's working properly?
Oh, excellent question. So, a couple different ways you can do that. You can set up another switch out here with a PC, and then you can use the functionalities of browser or mail or whatever and go to the servers that you set up here, right? And see if your access lists are working, your NAT's working, things of that nature. Okay? I'm really looking for connectivity more than anything else. So, well, the first thing I do when I grade, oh, also, unwritten rule. So word to the wise here because everybody loses points. What did I say about Lab 1 and Lab 2? What are you supposed to do after in Lab 3 and Lab 4? You're supposed to put all what? All those best practices of hardening in there, right? So what should you turn off? Or what should you turn on? Service password encryption, no CDP enable, lock out your aux port. Remember all that? I'm looking to grade that as well. Don't forget that, because guess what? Half the class is not here, they're going to forget it. You, lucky few, are going to make sure that you get all those points. Because that's typically where students lose points. They watch their videos, and they record everything, and they go, okay, I'm good. I usually don't say this, but since there's so few people here, I figure, you know what? I'm going to give you guys an advantage. Competitive advantage, right? Good deal. Any other questions? Nothing? Okay. So, show run. Right? Make sure that that's fixed. I look for no CDP run in here. It's not in there. Aux port's not locked out. I don't make it turn on SSH. Alright? I don't make you do an enable password. If you do, great. Don't worry. I showed you guys how to hack into these things in case you lock yourself out, right? So that's a bonus. That's one of the few things about packet tracer I do like. All right. In that case, nothing else. Next week, God, week 9 already. Damn. We will go over Lab 4 starting on Tuesday after lecture, and we'll get through it next week. I will try to get things graded. I've got caught up on grading this weekend so everybody knows where they stand as far as grade-wise is concerned. People have already bugged me about that. legitimately. I've been falling behind a little bit. And I will start next Thursday, I'll start prepping for the final, which would be 2 weeks out. Right? Yeah, 2 weeks out. Give you guys plenty of time to study. Because some of you did really good on the midterm. Some of you did not so good on the midterm. Alright, if you don't have anything, I don't have anything. Have a good weekend. I'm going to try to catch a nap before I go watch Deadpool tonight.
Pastor Brian, have you ever heard of a company, Accent Computer Solutions?
Yes, I have.
It's a good company.
I've heard good things, I've heard bad things. Run by a Cal Poly grad from a long time ago, a little bit older than me. Small business, great place to get some experience. Really great place to get some experience. Be careful, because the owner, and this goes for a lot of small businesses, the owners look out for one person only, their wallet. Alright, so work the wise. Now, typically they pay a lot less than other places. So are you looking to apply for a job there?
I got offered a job there. One of
Really?
My coworkers, my old coworkers, took a job there, and he said a position's opening up at the headquarters in Rancho.
Yeah.
For remote operations personnel. So.
Okay, so you're working with us.
Yeah, pretty much helped us.
Great place to get some experience. You know?
The only thing he said is that they won't work with my school schedule.
They're really jerks about that, but you're almost out of school, right?
Yeah, I have next year.
Yeah. That's I've heard that about them too.
Yeah, so I was like, oh, cause.
They're a managed service provider. They have set budget.
Yeah.
They're real stringent. If you're late to work, like twice, they fire you.
Yeah, that's what he was saying. And he was like, they don't have any female personnel, or very many female personnel there.
That's another thing you gotta worry about too.
Yeah, and I was like, well, there's not very many females. But I like that.
Larger companies, you're more professional. Fortune 500 companies, you will get treated far differently than you will in a small, medium-sized business.
No.
I guarantee you. It's not right. I don't agree with it. It's completely wrong. But unfortunately, that's the way it is. I hate to say it, but.
Well, because I was debating whether or not, because the real estate company offered me full time.
Oh, well.
And they're still gonna let me go to school, so